老师提两个有点外行的问题，就第一个是，前面讲到就是说我们把要3D 模拟化的东西生成物件场景，然后呢，如果说像一个橘子园里面，然后有橘子要让机器人去摘那种橘子的话，这种东西是属于我是要等于物件跟场景都要一起去做嘛。然后呢，那第二个问题比较事实一点，就如果像重建一个就是清大这样校园的话，大概业界收费的标准是？
业界收费的标准。好，我可以先回答第二个问题，因为业界收费的标准我们也不太清楚，因为我们都是大家来帮忙我们把这一件事情促成的，对对，但这个可能我猜空拍一次的话呢，以那个范围来讲，可能应该是10万左右啦。对对对，好，然后当然重建这一块，我们要怎么收这个服务费，这个我还没有一个底，所以如果有业界先进的话，想要合作，我还是非常的欢迎啊。对对对，我们现在还是比较偏 academic 的方式跟 NVIDIA 合作，然后一方面他们想要秀说他们的算力可以拿来做这一些事情啊，不然叫大家买那么多算力，总是要有一些应用可以 demo 的啦。对，那您刚才讲的另外一个情境的部分的话呢，其实对我来说，不需要分到说场景或者是物件，但是我会觉得，如果假设今天这个东西是要跟你的机器手臂去互动的话呢，那当然可能就要个别把它建出来。其实我这边有列掉一个细节，就是说，好，假设以今天我们的 case 来讲，我们能够把这个3D 的场景重建出来，以一个3D GS 来讲，其实它看起来就是一块皮跟一个可以碰撞的这一个3D 模型，但是他不知道这里是一张椅子，他不知道这里是一张桌子，所以其实还有一个后置的处理，就是说你必须要对你的场景做一些语义上面的理解。你要知道说，好，假设这里是地板的话，那地板你就用一块很平的地板去 model 它就行了，这样在里面做模拟还会更准一点。如果你今天是一个椅子的话，那你怎么样把这个椅子独立的切割出来，变成是一个物件，然后让它可以跟你的物件这边去产生互动，对对，或者是说有些东西是你，假设你那个橘子，你是可以独立把它建出来，然后把一颗一颗把它种在树上面去，那也是另外一种做法，对对。所以通常我们在物件来讲会比较偏是，它会需要跟你任务有关，然后跟它产生互动的那一些东西。那场景来讲，我这边比较狭义的定义就是那些静态的，反正它能够走，能够过去，然后撞到它也不会动，那个我们就把它当成是一个比较静态的场景来去描述它这样子。对对对，好，不知道这样有没有回答你到你的问题？
所以就是如果这样的话，农作物的场景要重建，其实它会变得非常昂贵，是吗？对，因为要看你做什么农作。如果像你橘子树来讲，我会建议啦，橘子就不用真的去建那一棵树了，你就现在有很多游戏引擎的那些树，其实就已经做得非常的好了。风要吹会动，对不对？那你只要想办法看你怎么去模拟那个橘子要摆在哪一个地方。对，因为对我来说，那个虚拟的话，我们如果常常有厂商跟我讲说，老师你这个模拟的环境跟真实到底能不能说100%？那他讲这个我就不太敢跟他合作，因为这个不可能达成的。对，而且我应该是要去思考说，有哪一些东西，有哪一些任务，我们可以前期的在模拟环境里面先把它解决60-70%。对，那最后你的30%、40%可能落地的时候呢，你那边就是你还是得要去收集真正的这个资料，才有办法把那个 gap 给弥补起来。对，上。对，你好。
朱老师，我问一个问题这个，好，谢谢。首先感谢那个朱老师非常精彩的演讲然后我其实就是接续刚刚那个先生的一个问题，就是说你建完3D GS 之后，因为我们知道，比如说你家里环境要去建这个3D 的环境嘛，那刚刚你有提到就是跟机器有互动。那你3D GS 建完，因为我们家里是应该都有很多那种零零碎碎可以移动的东西，那这个也会是以后机器人要主要互动的一些upgrade。那从你的角度来看，就是说你建完3D GS 有没有可能从3D GS 这个模型里面去把这些物件挖出来，还是说你在建这个环境的时候，你所有东西都先把可以移动的小物体或者什么先把它清空然后你去建完3D GS， 然后再慢慢去把这些小物体建出来，就是哪一种 approach 你会觉得是比较可行？就是 从 3D GS 我直接把这些我不要的这些可以动作这些物体从 3D GS 本身那个模型就一个一个挖出来，还是说我必须先清空，然后再把它加上去？哪一种 approach 我觉得会比较对一点？好，谢谢。
这个我会看我家里有多乱。对，我家里东西很多的话呢，我就一个一个把它挖出来。但是我家里东西不是很多的话呢，我们就是先清空建好，然后一个一个建再把它摆回去，这个是最容易的。对，
挖会不会就是挖不干净？
会，对，所以我说挖是比较难的。所以其实现在有一些叫做3D 高斯 object， 它就是你拍完之后呢，它就一个一个 instance 把它切割。像这样老师知道吗？我们用 SAM 很容易就可以把那个 image 的 instance 切出来。所以对我来说，我只是把每一个 view 的 send mask project 回去 3D， 那我就可以把它挖出来的。但挖完呢，你要去补它，所以其实是后面的那个修补是最麻烦的。对，特别是说你有一些东西，你可能不像桌子、椅子还简单，那补个脚，你补什么东西都不重要。但是如果你有一个模型，它是整个一半被盖住了，那你补出来的东西到底准不准，这就是另外一个问题要去解决的。对啊，所以如果是我的话，我会现阶段我们都是就是个别的去建，然后再把它摆回去模拟，这样是比较快，因为我们的现在的环境还比较单纯一点，现在还没有办法直接到家里就真的是出来，然后所有的东西全部都有，这个其实技术门槛还是蛮高的。对。
谢谢。
还没有人要问问题？
您好，我注意到您展示的场景中，有关流体，就是气体或者液体的画面好像比较少。我想了解一下，您是否了解，就是业界或者学界是否对这个的关注比较少呢？是因为复杂度比较高，应用面比较少，或者投入产出比较低等原因吗？谢谢。
好，这个问题很好，所以其实就是 apply 到现在黄荣兴一直讲的 physical AI 的那一块啦，所以那一块我今天没讲的话呢，第一个很重要的原因就是因为我数学没有很好，所以那一块我是真的没有涉猎了这么多。但那一块的话呢，我会觉得是未来 digital twin 最核心的一个部分。就像刚才我们讲的，我们都在讲到底物理这一件事情。那我只是有点沾到边，是说那我怎么去估测一个模拟可以用的物理参数？对，但实际上有一些流体，有一些气体，甚至是一些异质物体的一些互动的话呢，它其实是后面有一个很复杂的物理的模型公式去得到这个最后生成出来的这个结果。对啊，那这一块确实是很难，所以基本上现在产业上能够找到这样子的人才，懂物理，然后会拆解它的这一些微分方程，然后能够去知道说哪一些东西是可以用解析解的方式直接把它解出来，哪一些东西它必须要用 data driven 的方法去做这件事情的。所以这个其实是不是产出效能的问题，这是人才的问题。所以现在台湾在这一块其实他们知识没有办法就是那个跨到那一块，所以如果你对这一块很有兴趣，我强烈推荐你来听那个倒数第2场演讲，洪世轩老师的，他就是在做 physical AI 的部分，所以他那边也会介绍模拟流体的这个模拟，然后气体的这个模拟，甚至我们最近在研究的就是说刚才讲的 sensor 的这一个模拟。那我可以举一个简单的例子，像那个大家不知道有没有听过，有做模拟的应该有听过一个公司叫做 ANSYS。对 ，ANSYS 它就是做模拟非常强的，它做各式各样工程的模拟，但它的问题是什么？很慢，对不对？它作为一个模拟，可能1分钟的模拟，你可能要跑好几个小时啊，这个跟digital twin就不合了，因为digital twin希望很快的看到这一个结果。所以现在 ANSYS 他们做的一件事情就是说，他们用他们很慢的这一个模拟，但是他们的模拟拟真度会比这个物理就是游戏的用的这个物理引擎要高上一个 magnitude 的情况下，他们把那些东西变成是一个 data， 然后直接就是训练一个 neural network。我看到一个 observation， 我的 input 的 parameter 是什么？那我 output 的这一个 visual 是什么？他们就直接把这样子 overfitting 到他们的模拟上面去。 对对对，所以这一块其实就是所谓的叫做 PINN 我有点忘记全名是什么，反正它的概念就是你用大量的这一个资料去训练你的 neural network， 让你的 neural network 能够去 reproduce 你的这一个物理的一些 scenario。对啊，那我会觉得现在还是很难找到一个 general 的 model 可以 cover 所有的物理啦，所以未来最早落地的应该会是说针对某一些 specific 的情况例如说，假设我是在做这一种制造业的，那我要做一些热模拟或什么的，我就是在那样子的一个 specific 的这个 data 里面，我想办法去收大量的资料，然后想办法去 overfitting 它那个情况，因为对业界来讲，他只要能够解这个问题就好，他不 care 你流体是不是也能解，我只要能够解热这一件事情解热传导这件事情，把它问题解决就可以所以未来物理的 AI 我认为会越往这一种 domain specific 的方式去做发展。对，好，不知道这样有没有回答到您的问题？好，谢谢。
教授好，我有个关于场景重建的问题，就是目前以 3D GS 来说，就是它的渲染效果十分好，但是我们从这个 3D GS 要转回 Mesh 之后，它的保真度会下降嘛？那以目前来说，就是场景重建有另外一个方式，就是透过神经网络去 predict 出我们的点云，再去重建回 Mesh。那这个点云上面还可以附着颜色。那以教授您研究的角度来说，因为目前这个 3D GS 往后就是在未来的应用上面，那我们想要保留它的保真度的情况下，是有就是这是可能性上高的，还是我们以环境重建来说会往另外一个方向去走？就是我要保留这个 Mesh 的保真度来说的话，就是以教授角度来看，3D GS 往后的路是会怎么看这样子？
我觉得你问的问题非常好就是那个 3D GS 未来就会朝你像刚讲的用 neural network 的方法先去帮它拆一个 geometry 出来因为我今天省略了 3D GS 的一个优化的过程优化的过程是从那个 structure point 里面 SF structure from motion 里面的 point， 那如果学 CV 的人都知道那个东西是很稀疏的，然后甚至密度是很不均匀的，对，然后接下来它是从每一个点，那觉得那边不够，它就一直涨，然后透过它跟影像对比的算出来的 loss 的 gradient 去决定它要涨还是要合并。对，所以其实 3D GS 早期会有一个诟病的话，就是说它很容易长出一些多余的点出来。对，所以后来最近的几个所谓的这种 foundation model 兴起之后呢，像 VGGT、part3 还有这个 depth anything， 他们的概念就是说，反正你给我影像，那我就想办法把这些深度的东西跟点云的东西很 uniform 的帮你预测出来。一旦有那些点云之后呢，你就不用再去增生了，你就是每一个点云，就像您刚才说的，直接给一个 3D GS 的参数，接下来就直接在那边开始训练。那这样子其实它就能够在几何跟品质上面都能够得到不错的一个 balance， 所以这个也是未来的这一个趋势，没有错。对。
我有问题，那个我之前有听他们讲说那个Google 他们也算是 World Foundation Model， 他们是从那个 video， 因为我刚刚跑出去了，所以他那个 World Foundation Model 是从 video 然后去预测它下一部分去产生的，叫
interactive 的嘛，还可以玩游戏之类的那种概念。
就是基本上他们说他们的 Gemini Robotics 基本上就是因为有大量的 video 去预测就假设从人视角看到下一步会怎么样子，所以他可以预测这个东西会怎么样子被拿取。所以他们的那个Gemini Robotics 部分，他就很有办法去预测说我怎么样子去拿它，然后接下来会是什么样子。那不晓得说您刚刚介绍的 World Foundation Model 跟这个 Gemini 的那个 Robotics 他们的一个做法上面是不是有相同或者是相异的基础？
对，我刚才讲那一个 Cosmos， 其实它有分3个部分一个是 prediction， 然后一个是 transfer， 然后一个是 reasoning。那我刚才讲的比较，因为我今天是讲 domain randomization， 所以我是讲 transfer 那一块。所以 transfer 就是走传统的那个 CV 的 image to image 的 translation， 所以它把它拟真度提高。所以它还有一个叫做 prediction， 它就是可以预测，假设你今天要动的时候呢，我猜他们应该所谓的 foundation model 都是就是本质上骨子里面都是 做一样的事情，只是他用不同的资料或是他们自己独门的一些方法架构上面的设计做调整。对，但他们就是可以预测，是说，假设我今天看到这一个机器人做什么样子的一个步骤，那下一步应该会做什么？其实就是我们现在大家比较耳熟能详的 VLA， 就是在做这样的事情。那 reasoning 的话，就是你给我一个 action， 然后它可以帮你去做这个东西的描述，就是 VLM。对啊。但是其实，在机器人，那个 Google 那个不好意思，我那边就没有 follow 到。对，然后但是 NVIDIA 那边我相信大家都有听过，他们在去年的 GTC 有提出一个叫做 Groot 的一个机器人的模型，就号称说你用我这个，你可以很快的把你机器人的模型的任务部署到另外一个。对，那所以他们强调有2个核心训练的，第一个就是我刚才讲的，我在 simulation 里面，然后去做各式各样子的任务，然后再来的话就是他用他的 Cosmos 把画面变得很精细。这是一个，他们在那边好像收集了大概20几万笔资料，对，然后另外一个他们号称就是说这种 demo by 的这个generation by demonstration， 也就是说你只要给我一个真实，他们有一个真实机器人去录他们要的这一个 task， 然后接下来他们就是给少量的这样的资料之后，他就完全不透过建模，他们就是透过我的 prediction reasoning， 然后还有一个trajectory 的 generation， 他就可以知道说，我可以有他各式各样子拿的这一个方式，然后呢，在这个 video 过程当中，他们会回去推敲每一个关节的这一个系数。大家如果有在做机器人，应该会知道，最后机器人要的训练资料，要么不是 RL， 要么就是 imitation learning。那 imitation learning 你就是要跟他讲，你做这一件过程当中，你所有关节的这一个系数跟 end effects 的一些参数，让他去学。对，所以他那时候主打的就是这2块，对。但有趣的是呢，我们也把这个东西整个拿过来，我们想要 base on 它的 Groot 去 fine tune 我们自己的这一个 task， 对，因为我们不想要做重新的3D， 我想说他说很厉害嘛，他说以后你只要给我做几次，拿50笔或30笔的资料，对，这个录音他们会听到吗？对，但是这是事实发生的事情就是他们号称说，你只要给我50笔、30笔，你真正的机器手臂，即便跟我那一只机器手臂不一样，你真正的机器手臂在做的这个事情，然后你用几只相机把它录起来，我就可以帮你把这个模型 fine tune 可以完整这样子的 task。我们就发现不太 work， 对，发现最后呢，只能拿他学的那个 task， 就是把东西拿起来放到另外一个地方。对，你 generalize 到其他的 task， 你要做什么组装啊？我发现完全都训练不起来。对，所以训练不起来最大的问题是，他们号称从 video 去做 augmentation， 然后不透过建模，也不透过模拟做 augmentation， 然后直接去 predict 的那些机器手臂的参数，那个其实资料是非常不准的。对，所以我们也很好奇，我们也就问 NVIDIA 的人说，那你们没有试过？你们说你们用 synthetic data 那个20万还是多少的？然后他们说他们用那个 video 的那个产生了大概8000多个小时的 video， 对，可是他们 paper 很有趣像那个林老师知道吗？我们都会做 abbreviation 嘛，我们都会说那到底这个的贡献多大，这个贡献多大都没有做，因为他们就直接就全部都混在一起，就说加起来就好棒棒，对，然后所以到底后面那一个 video 的 effectiveness 到底多强，这个其实现在还是不知道。那我们也去问他们内部的人说，你们知道这个？他们说好像他们也没有想那么多，因为当时 Jason 要他们就直接就先赶快做，然后用大量的资料，然后反正看到效果有出来就可以 announce 了。对，所以其实那一块要从 video 去 generate 可以 training 的 data， 我认为现在其实还是有一个蛮大的这一个 gap， 但是我觉得这个可能是未来会发生的事情。当你的那些 world model 真的看的资料够多的时候，我觉得还是有可能会发生。但现在我们在做一些 project 的话，我们还是比较走，你得要做建模，然后做模拟，然后想办法把一些 domain 的问题提升视觉的提升，然后产生训练资料。至少在那个地方，我们可以保证我们收到的资料是干净的，是可控制的。对，好，上。
好，各位好，我是 Melvin 这个部分的话是那个 hands on 的东西的部分。那我这边是 朱老师的川底生，然后我是那个主教，所以即使我是外籍生，所以好像要用英文讲的。好
，OK 的。
那就是要请你们扫一下 QR code， 里面有一些那个材料，可以先安装，可以先下载这样子，看一下。好，这样，这边有一些材料，你们可以先下载。好，那因为我们这边只有，好，对，我们这边只有30分钟，所以我讲话要更快一点。好，从这边开始我会用英文讲。And okay, so all right, so this is our hands-on activity. So what we are going to do in this hands-on is we have 3 main parts here. So the first one is the 3D reconstruction with Litchfield Studio, and we're gonna learn how to reconstruct, how to a 3D scene using from captured image, and how to explore some basic workflow for training and inspecting a 3D GS scene. And then we're gonna move on to the Marlboro World Lab scene generation, where we're gonna learn how to generate a world scene only from text prompt, or maybe some images, or maybe some other type of inputs. And we're gonna see how we can prepare the scene and how we can import it to a simulation app like Isaac Sim in this case. And then we're gonna, last part is we're gonna demo about the replicator and some domain randomization in Isaac Sim. Oh, and this is some requirements that I expect you guys have already installed. Okay, and let's move on to the first part, 3D reconstruction with Litchfield Studio. So our goal here, we have some multiple images of the same scene, and how do we construct a 3D Gaussian splatting scene representation? So this is our end goal. Yeah, so we have a 3D GS scene here. So we're gonna reconstruct this using Litchfield Studio. So first we can open the Litchfield Studio app by going to this bin litchfieldstudio.exe, and it will open this window right here where we're gonna use a NERV 360 dataset in this case, which consists of multiple scenes with a lot of images, multi-view images, which also contains a camera poses in this case, which is required for our reconstruction here. But feel free to choose your own dataset for this experiment, but keep in mind that each dataset requires a different tuning depending on its size and scene complexity. So I will use the kitchen dataset over here, so we can drag the kitchen dataset folder here into the Litchfield Studio, and then we can hit load when we're ready. Okay, and these are the camera poses loaded from the dataset. So we can see that multiple camera positions and poses over here, and this is all required for the reconstruction process. And each scene typically contains 100 to 300 images with the camera parameters included as well. And this is some basic layout of Litchfield Studio. So this is the toolbar of the program. So we can switch between views like the perspective and orthographic over here, and also some scene, camera rendering, and some training parameters. And then this is the scene hierarchy, which we can show the loaded data, all of the cameras poses here, the point clouds, and also some training result later on. And this is the training parameters that we're gonna modify as well. So we got several basic training parameters as well as some more advanced down there. And as Professor also mentioned before, we have some strategy built into the Litchfield Studio where we can also 调整它的那个参数这样. And this is my recommended training parameter only for this hands-on, which is very fast. So we got only 5,000 iterations with max Gaussian of 1 million. But I think this one is not going to result in a good scene. But here I have some demo video where I demonstrate the result when I use 20,000 iterations. And I speed this video up by 20x. So we can see that it starts from a very rough scene or like a very latent 3D-GS result, and after a few thousand iterations, it becomes more clear. Yeah. And here I also have some demo, so I can try to So here's the training result after 50,000 iterations using Litchfield Studio. Okay. So this is the kitchen scene. So we can as well navigate around the scene over here. Like we can right click and then middle click to rotate around the scene. And here in the scene hierarchy, we can see the training result Gaussian splats where we can also hide and unhide it over there. Yeah. So there are actually a lot of features built into this program. Maybe we can explore it later on in the next hands-on. Oh, now what issues, man? Okay, so how to export the scene as PLY format? So it's very simple. We can just go to this file here and then export, choose the PLY format, and then it will export the PLY format as correctly. The next part is the Marble World Lab scene generation and reconstruction. So again, the goal is we have this panorama image, only a single panorama image, and how do we reconstruct it into a fully simulation-ready scene using Marble World Labs. So first we can visit this Marble World Labs website and then create an account or log in with Google or GitHub. And then once logged in, we can go to this create panel where we can put in our our prompt and input here. So first we have the 2D inputs where we can add multi-view images and some videos as well. And then we can also have this 3D input and then the text prompt just for very simple scene generation. And here I try to generate a scene from a prompt. So this is the prompt that I used ChatGPT to generate this prompt. And then I just add the input prompt here and then hit create there. Then this is the result. I can say that this is very, very accurate already. It's very perfect already, I'll say. Yeah. But probably we need to clean some of the outliers in the 3D.js scene because it's a bit noisy sometimes. Okay, and the next one is the panorama image to scene where we have set of panorama images and how do we reconstruct it into a 3D.js scene. In this case, I use this data set where we can take a look at some of the data sets and download it as well. And here we can import the 360 panorama view directly as the input here, and it will show as a panorama icon here. And here I use this specific panorama image where I download from this one. So you guys can also try to generate it by yourself. And this is the result of the 3D.js scene. And also what I like about Marble World Labs here is that we can take a look at the interactive scene over here. Wait, let me see. Yeah, so they got a front end, I would say like an interactive scene where we can navigate between the scene and also we can render a camera view as well. So we got a lot of exporting format, and then there is also some record where we can add a keyframe in our in the web browser, and then we can export the video as well. And this is the exporting, has also been mentioned by Atul also Japan. And here we can export the scene here as a PLY format, and then, or we can also use the low-res PLY format, is also fine. And then we also need the color mesh for the physical interaction later on. So here I just choose the splats here and then the color mesh and export it as the PLY and GLB format. And okay, so we got the PLY format already, but we need to convert that to a USD format, which is supported built-in by NVIDIA Omnius platform. So here I just use 3DGRUT tool, which also worked by NVIDIA. And it is currently supported on Linux. So here I just use WSL on Windows if you want to set this up. And then I can run this following command. And it will export the USDZ file format here. So we can import this directly into the simulation app. And this step may take time to set up. So I have provided with a final USDZ file in the Google Drive hands-on folder. So feel free to download the final scene. Yeah, so this is the Google Drive where the hands-on Marble folder I provided with every PLY, GLB, and USDZ file format as well. So which just can be directly imported to Isaac Sim. So next one is Marble roadmap to Isaac Sim scene setup. So the goal here, we want to, from the raw file, from the exported scene, how do we import and concatenate it into a single scene? And I also add some cube here to demonstrate the physical interaction between the scene and the physical objects in the scene. Okay, so make sure you got Isaac Sim 5.1 or 5.0 or 6.0, I think that's fine, and can launch the application successfully. And you should see this blank empty scene after launching the application. And here is some interface. So we got the viewport over here, which is the scene view perspective of the scene. And then we also got some stage window over here, which shows all of the scene hierarchy and all of the objects that we put in the scene. And then property panel. So for example, if we choose this default light, it will show up here. So we can modify the transformations of the object as well as some of other properties. In this case, if there's a lighting, it can we can also specify the intensity of the lighting, the angle, and so on. And this is the browser where we can put in the path of, for example, a folder, and then we can drag and drop a file and an object into the scene as well. Okay, so first, after we download the file from the Google Drive, we can copy the path and then paste it into the content window of Isaac Sim. Oh, this is the video. Yeah. So we can just copy the path of this folder and then we can paste it on the content path over here. So it will show up with these 3 files that we're gonna use. Next one, we can drag the kitchen world USDZ here, which is the splats or the visual geometry of the scene. And then we can just drag and drop it into the scene here, or we can drag and drop it into this world on the stage window over here. And it will show up as this 3DGS scene, which is very cool. So this is my demo of doing it. So you can just drag it over there, and then we can also navigate between the scene using right-click button and then WASD keys to navigate in the scene. And then to enable the physical interactions in the scene, we need to add a collider mesh in this case. So in the stage panel, we can expand this kitchen world, so which is the SandiGS geometry for X form in this case. And then we can expand it until we got the Gaussian X form here, and then we can drag the world collider GLB file from the content into the X form of the Gaussian. So this will automatically merge or like combine, attach the collider mesh into this hierarchy over there. Then we can right-click on the world collider here and right-click and add a physics collider preset into the object. This will apply a physics collider API into the collider mesh. And then we can also hide the collider mesh geometry here to prevent it from appearing black in the scene. So this is the before, and this is after I hide the mesh 0 of the collider mesh. So it appears clean, and it will also preserve the collision API as well. And to visualize the collider API, whether it has been successfully applied, we can temporarily enable the show collider view on this view icon here. And it will show up all of the pink like triangle collision visualization. Some demo. So first I add a collider preset into the collision, and also enable the collision type view. So we can see all of the colliders have been applied successfully. Then we can hide the mesh over there. Okay, so next one we want to add a cube. So we can just right click on the world prim here and create a new mesh. And we can choose the cube. And it will directly put in here, but there's some problem where the scale is wrong in this case, because the scene is too small, and this cube has a default unit of 1 meter by 1 meter. So the scale is 1 meter by 1 meter. So here I try to add a new transform in the kitchen world X1, and then I set the scale to be 2 on the XYZ scale. So this is the result. So it looks more reasonable. And then we can click play the simulation and then try to move the cube around. We can hold the shift key and drag the cube around to see the physics in actions. Okay, and the results. From now on, we have the simulation ready scene with 3D.js using Marble and a collider mesh applied. Now we can move to the next hands-on part. Oh, so this is the domain randomization with replicator in i6. The goal of this hands-on part is we want to add autonomous mobile robot in this case, and then we want to add several properties assets into the scene and run a domain randomization by replicator, and then export the data sets with replicator synthetic data encoding. It seems quite complex, but it's actually very simple and straightforward. So we can just follow along with this demo here. So first, AMR stands for an autonomous mobile robot, and in this demo, we'll use a Nova Carter robot, which is made by SIGRobot. And I will also set up its differential controller, so it can move around in the scene. And then we can also use our keyboard to control the robot movement. So this robot is actually very simple, and it doesn't have that complex movement, I would say. So we can just add a differential controller for this specific use case, and it will work this way. So first, we can go to the window browser i6sim here, and then we can find click on the robots category here and find for the Nova Carter USD file. So we can drag this robot into the scene. So here I just drag the Nova Carter to the wall and position it on the floor. So it will appear as a USD robot as a reference over here. So we can just position it on the floor. And to move the AMR robot, we need to add a differential controller. So we can go to the Tools tab, Robotics, OmniGraph controller here, and then choose this differential controller. And then we can copy these settings of the differential controller here. So first we need to add the robot primitive. So we can just choose here, add, and then choose the Nova Carter robot. And then for the wheel radius and distance between wheels, I just use this not really accurate parameters, but it will work. And then we can also set the right and left joint name of the wheel. So this is required for the movement to work. And then if we want to control the robot movement, we can use the keyboard control, the WSD here, and check it here. Then click OK when you're done. Then we can play the simulation and press the AWSD to move the robot. And all of these the robot already are interactable with the scene already, because we already add the collider preset into the scene. And to perform a simple randomization with replicator, we will add several props to the floor here and create some scattering surface, and then we also have some script, and we can run the script and it will randomize all of the objects' positions and rotations in this case, if it chooses. And then it can also be interacted with the robot here. So yeah, so this will be very useful if you want to train a robot, or maybe VLA or VLM model. Okay, so i6sim has a large library of assets. So we can go to the i6sim assets window and go to this props category, where we can see a lot of props image, props objects USD over here, and we can drag several items onto the world and position it on top of the floor. So this is the result. So I got like 5 different objects that I placed on the floor. So this is just for demonstration. So okay, so we need to add a scattering plane, which will be used as a surface for the scattering area, as well as we're gonna use this as well to make the robot movement more smooth. So to add a plane, we can right click on the world, create a mesh, and then click on the plane. Now we can align the plane accordingly, just above the floor, and also scale it up properly. Yeah, and this plane will be used for scattering surface area as well as making the robot's movement smoother. Because if we can see without the ground plane, we can see that the robot movement is a bit like bumpy in this case. And it's because like when we derive the collider mesh using a 3D geometry, it can sometimes have a inaccurate and more dense mesh. So we can add a ground plane here to make it more smoother. So this is the result with the ground plane. So we can see that the robot moves very smoothly in this case. And there is no like bumpy or weird effects going on here. Now make sure to add the hardware preset as well into the plane, so we can see that the plane will have this collision area. And to simplify the randomization process later, we're gonna group the randomizable objects under a single X form. So we can create a new X form. So this is like a group, or yeah, we can say it as a group, but it is an X form. And now we can drag all of the objects under the X form. Then we can select all of the X forms as well and add a rigid body with a color preset. So this will add a physics into all of the objects in the scene. And after everything set up correctly, we can directly run the scatter 2D script that I have provided in this Google Drive. So we can just open the randomization script demo here and then copy all of the content and then paste it on the script editor window. So we can also open the fully configured scene. So if you don't want to if you don't want to follow along with every step that I just did, so we can just open the fully configured scene here as a USD file, and then just open the scene in ASEC. And to run the script, we can copy the entire Python code and open this Windows script editor window and paste the code and then click run. So the objects will be randomized correctly. The positions and the rotations will be randomized in this case. But there are still a lot of ways, a lot of possibilities that replicator randomization can do. For example, like to randomize the lighting parameters, the physical parameters, the textures, and as well as some other randomization too. And also don't forget the pixel level data augmentation, where we can also add some noise, some blur, some transformation to the final render outputs of this scene data. So here I use the built-in replicator scatter 2D function to randomly distribute the objects on the scattering surface with collision handling enabled. So this is the API from the randomizer here. So I just use this function and define the scatter zone of this is the plane that we're gonna use for the scattering area. And then we can check for collision, set it to true, where it will check between objects collision. So that's why we added a rigid body and color preset for all of the X from before. And then we can also randomize the pose here, which is also built into the replicator scattering tool. And here I use the pose here to randomize the rotation from this uniform. So I just use the Z or the yaw axis of the rotation axis. So after completing the setup, we can capture the scene data and export it locally. So we can open Tools, Replicator, Synthetic Data Recorder, and follow the settings below. So we can choose the basic writer or the default writer in this case. and check some of the parameters here. Here I check the RGB, semantic segmentation, and instant segmentation. By the way, the script that I provided in the Google Drive already includes some labeling for the objects. But we can actually tune or modify the object label by ourselves as well. So after that, we can start the recording by just pressing this button, and then it will export all of the files here. And this is the result. So we got the RGB color, instant segmentation, and semantic segmentation, annotators output. And now we have finished the demo. But here, since we still have like 5 minutes of time, so I will demo this directly within my Isaac sim here. Just for So first we have to download the scene folder over here. So on my Google Drive, we can go to the hands-on randomization and download this folder where I already have this collect fully configured scene USD file. And then the script as well that we're gonna paste into the script editor. So I'm still opening the Isaac sim here. Ah, 如果有问题的话，可以举手。一样的，对。诶，是吗？我即使这个投影片是这个 hands-on activity 的答案，这样
是 preparation 是 on activity。
hands-on activity 的投影片。如果你开是那个 hands-on preparation 的话，都是 appendix。如何安装 Isaac sim 的话，然后如果你要登入那个 Marlboro Labs 这样子。Okay, so Isaac sim has been opened successfully here. So we got the content browser over here and then some property stage, and this is the viewport. So I will use the downloaded assets and scenes. So it's on my lecture hands-on modified scene out. So this one. So I can just copy this folder and then paste it into the content browser over here. And it will show up as this. We can just double click on this to open the scene. Okay, so the scene already contains all of the required steps to do the randomization. So we have the plane over here, the robot that we can also move. So if we click this play button, where we can simulate the whole scene, we can use WASD to control the robot. And actually the robot already has its own camera. So we can go to the perspective cameras and change to the third person view camera, which is already configured within the Nova Character robot. So I will just go back to the perspective mode. And all of the objects here are still static, which means that it cannot be, it is already physically enabled. So we can move or push the objects around there actually, since we already add the physics collider preset onto each assets. So we're gonna open the window and then script editor to open this script view where we can run our script later. and then we can just drag it here just for convenience. And then we can copy the randomization script demo over here. So I'm just gonna select all and copy. How? And I'll move to something. And then we can run the script. And it will automatically randomize all of the objects under the X form that we specify on here. So that's why we group all of the items, all of the objects into a single X form for more convenience randomization. So we can run this multiple times and it will randomize all of the objects within the specified surface area. And the surface area of the randomization is this plane right here. So it's gonna sample only in this sample area over there. Oh. And after we do the randomization, we can again click play the simulation to interact with the new object poses there. Oh, I think that's all for the demo, but I still have some resources here, which is also very important. So I also got some Notion page here to demonstrate how we can convert the Marble World Labs scene into USDZ with 3D GRUT. And here I already got every step-by-step shown here, as well as some of the transformations, modifications, and so on. I also add some ground plane, cube, and then some robot at the end. And then the next resource that I want to mention is this NERF dataset, which is also very, very useful for our research. Oh, this is the NERF. Yeah. So it contains a lot of data sets that we can use in our research, or the scene construction, or the scene generation process. And this is the Sandy GRUT repository, where it already contains the tool for conversion from PLY format to USDZ. I think it's on the 3D GRUT, and then script, utilities, and then there is some render, so on. I think I forgot the name of it. Sorry. And the next one is we got some official documentation, where if you got some problems where during the installation of iSigSim, you can revert to this documentation and look at some of the solution provided officially by NVIDIA. Or maybe if it's not useful at all, you can Google directly on, they also have their own NVIDIA forum as well, or maybe in the GitHub issues repository. And then there is some one of the reference for this hands-on demo over here. So this is the documentation official. This is the official documentation of the data augmentation and replicator part. So this is the we can also do some pixel level data augmentation, where we can add some noise here, some blur here maybe, or some of the camera poses and so on. They also got this sample code where we can just directly run this in the iSigSim and it will work. And this is the writer augmentation, where we can use the writer API to export the scene to the exported annotators data. You can specify all of the randomization or the data augmentation, like the Gaussian noise and depth and so on. Okay, so the last resource that I want to mention is the replicator eyesight randomization. So this is the whole randomization code snippet that we can run for example, this randomization light source, where we can randomize the light source, the light intensity, the color of the light as well, which is very cool. And then the texture of the materials, and then the right down here we got the screenshot randomization, where we can have some like multiple frames, and every frame it will generate and randomize a different parameters, set of parameters. This is the physics-based randomized volume filling. And then we also got some yeah. And don't forget to mention that we can also do the randomization within the ISAC graph, OmniGraph built-in graph system. So we don't have to use the Python code in this case as well, which is also very cool. What's called explanation? Yeah, so this is the graph, OmniGraph inside the ISAC sim, where we can also do some randomization and data augmentation as well. 好，使用者。